Hello again, everyone. Let's talk about practice test number 3. Problem number 1. Solve the following proportion for x. Again, this stuff gets discussed in various places. This thing called cross multiplication is probably the easiest way to do it. You go here, you go there. 17 times x is 17x. 6 times 5 is 30. Divide by 17 on each side. X equals 30 over 17. 30 over 17 is 1 and 13/17. So you can also do a decimal expansion, depending on what you're being asked, guys. I mean, that's something at this point. Let's know the procedures, and we're always a calculator step away from getting any kind of an answer in terms of decimals, if we want it. So we got that right there for number 1. Number 2. For number 2, they're saying solve for w. And they've got w minus 2 over 4 equals 5/3. Tell you what, they didn't put parentheses initially, but let's put them here. Let's go for it. 3 times the quantity w minus 2 is this. 4 times 5 is 20. 3 times w is 3w. 3 times 2 is 6, and 20 is 20. Let's add a positive 6 on each side. Same procedures as in the past. Minus 6 is plus a negative 6. Negative 6 and 6, they go out, they're gone. You got 3w equal, add these two, you get 26. Divide by 3 on each side. (26 over 3). 3 goes in here 8 times. 8 2/3. 8.6 repeating. There's a lot that's there for us, I guess, for an answer. You got this. They all mean the same thing. If they say round it to a particular place, then that's something to keep in account. But they're just going with 26 over 3 on this one, and that'll work. Let's take a look at 3. 3, there is a sales tax of $12 on an item that costs $128 before tax. The sales tax on a second item is $6.75. How much does the second item cost before tax? Kind of a neat one. You got to be careful, but let's do it right. Let's go small over big. $12 in sales tax compared to the original before tax price. $6.75 in sales tax compared to the original before tax price. Well, wait a minute. If I'm paying $12 in sales tax, when the original cost of the item before any kind of tax was $128, well, $6.75 is considerably less than $12, so the original before tax price should be considerably smaller than $128. But there's your setup. When you do that, you can go like this, and you can go like this. Let's cross multiply. We've got 12x. 12 times x is 12x. We got 128 times 6.75. There's some tricks to this thing. We can maybe even do it in our heads, but it's pretty far. It's pretty far-reaching, I guess you could say. I could say 0.75 is 3/4 of a dollar. 3/4 of this is an interesting question in its own right. You get 7, you get 32, you get 96. You get 96 plus 6 times this, which would be 780, 768. That's 864, I'm thinking. Now again, this I'm doing in my head here, and I don't, I shouldn't try to be showing off, especially when I'm probably going to be wrong. But the way I kind of looked at it was 0.75 is 3/4. 3/4 of this is going to be 96. 96 is going to be added on to whatever this product is. I'm getting 780 minus 12. I'm getting 768. 768 and 96 is 864. I think I'm going to stay with that, guys, to be honest with you. But let's confirm it. Let's confirm this, guys. 6.75 times 128. 864. Sounds pretty good. So we're looking at this. How's this thing going to play out? Well, I mean, I got this right here. Again, we got the calculator, guys. You don't need to try to be too much of a big shot with this stuff, but let's just see how this thing would play out if we were to do this. Let's divide by 12 on each side and see where it's going to go. X equals 864 divided by 12. There's tricks to this, I guess you could say. If that were 900, your answer would be 3 less than the division with 900. So if it were 900, you'd get 300, you get 75. I'm saying 72. There's some tricks to this. I don't know for sure that this is right, you guys, but let's go for it. See where it goes. $72 it is. So sometimes you can luck out. Get these. There's a lot of ways you can do this. You can do it longhand. You can do it in your head. If you're comfortable doing that, or longhand, obviously you're allowed to use your calculator, guys. So there's no reason to make too big a deal out of it sometimes. But there we go. It's looking like that. Makes sense. It doesn't cost as much as the other one cost because the tax on it wasn't as much as the other one had tax on it. So that's kind of an interesting thing in its own right. For question number 4, they're saying follow the directions below, find out what's going on, and see what they're saying here. All right, let's see what we can say about that for number 4. For 4A, they are saying rewrite the percentage in the sentence below as a decimal. Yeah, pretty straightforward. One energy drink tested had 58.6% of the amount of caffeine contained in a cup of coffee. 58.6% means 58.6 per 100. If you divide by 100, they wanted it as a decimal. Let's get it done. 0.586. B, rewrite the decimal in the sentence below as a percent. A mayor spent 0.7 of her yearly income on the campaign. 0.7 is the same as 0.70. Take a walk 2 places to the right, and you got this. Whenever you got a decimal, you walk 2 places to the right and call it a percent. Whenever you have a percent, you go 2 places to the left and call it a decimal. So if you got a decimal, go 2 places to the right, you can call it percent. When you got a percent, go 2 places to the left, you can call it a decimal. There's more to it than that, but oftentimes this works just fine. So we did problems 1 through 4 here, guys. Let's go onward with this and see where we can go. Okay. For number, let's see here. For number 5, Greg started to run on a treadmill after setting its timer for 77 minutes. The display says that he has finished 37% of his run. How many minutes have gone by? Round your answer to the nearest tenth. Well, I mean, guys, there's a lot we can say here within the context of this problem and generally. When they say this to us, when they say what, it means X or Y or Z, etc. Some unknown quantity written in terms of a letter. They say something like that to us, okay? That's what is. Of means times. Is means equals. How many minutes have gone by? Well, the amount of minutes gone by, I don't know. What is the amount of minutes gone by? The amount of minutes gone by, X, is 37% of the 77 minutes total that he had set for the timer. Percents are useful to visualize a problem. They're not very useful in and of themselves to solve the problem. You want to convert them to a fraction or a decimal. Here's the decimal for you. You multiply them together, round your answer to the nearest tenth. So you got 0.37 times 77. $28.49. $28.49 minutes exactly, but they're not asking for an exact answer. Round your answer to the nearest tenth. If it's 5 or bigger, you round up. Simple as that. Not bad. Answer the following questions. They're kind of going along the same lines that we've already gone, guys. For number 6, 6A, 256% of 21 is what number? 250, let's interpret it. Let's use what we have over there to the far left. 256% of. Didn't we say of means times? Is means equals. What means? Well, we don't know. I mean, we don't know something, so it's X or Y or Z or something. 256% of 21.5 is what number? I don't know what it is. I got to figure it out. Make that into a decimal. That'll get us there. 2.56 times 21.5. $2.56 times 21.5 is what number? That's 55.04. That's A. What's B? 6.81 is what percent of 45.4? That's kind of interesting. Be careful here. 6.81 is what percent of 45.4? We got to solve for x. We're going to get a number that's not a percent, but we can convert it to an equivalent percent. It's a very good question, the way the question is asked. That's for sure. Let's try it again. They're saying 6.81 is what percent? 6.81 is what percent, I don't know, of 45.4? Sounds good to me. What we're looking at is 6.81 is, doesn't matter the order you're multiplying, it's a little easier to look at it this way. Divide by 45.4 on each side. X is going to be this. Now, this is a proportion. It's going to be a decimal. It's not a percent, but you can convert it to percent the way we know how to convert to a percent. So what happens here is, there's a number of ways we can do this. Let me cut to the chase a little bit on it. When you do this division, this is going to, yeah, right. It should be fine. What's going to happen here is this right here should give you 0.15. That's not a percent. But if you walk two places, to the right, you've got it. So that's it. I mean, let's just confirm. I've looked at the answer key. But 6.81 divided by 45.4. .15 it is. 0.15 as a decimal is equivalent to 15%. So there you go. We got it. We're looking good here, guys. So that's 6. Let's go onward. 7, 8, 9, 10. Okay, guys, let's keep going with this. For question number 7, we are asked the following. The next model of a sports car will cost 13.2% less than the current model. The current model costs $59,000. How much will the price decrease in dollars? What will be the price of the next model? This can be done a number of ways. If it's going to cost 13.2% less than what it costs now, 13.2% times 59,000 is going to tell you the amount of the discount. So the decrease in price, when you actually do that, we'll go with what they're doing, guys. I'm going to have faith that they're not doing something bad to us here, but they're doing it right. When you actually do the mathematics on this, you're talking about 0.132. 0.132 is 13.2% times 59,000. 0.132 times 59,000, they got 7,788. They got 7,788, 7,788. I agree. Absolutely. That's the amount of the decrease. What's the new price? I mean, that's a good point. So the new price is simply going to be 59,000 minus the decrease. Well, that's going to be 51,212. Let's make sure here. Yes. Did they make it A and B in here? They might have not have said A and B, or did they? Did not. I mean, I called them A and B. I called them A and B. You don't have to, though. This is the amount of decrease, and this is the new price after this amount of decrease. Take this amount of decrease and take it away from this guy, and you're set. You also could have done, kind of a slick way to do it is, if you're dropping it 33.2%, what's 100%? You don't have to go any further, but if you wanted to, what's 100% minus 13.2%? Whatever that is, multiply it by the 59,000 and you'll get the new price of the car. If you do the subtraction here, this is going to be 86.8% times the new price of the car, which is the same as 0.868 times 59,000. You want to bet, so you're taking it off of 100%, taking 13.2% away from 100%. This is what the price of the car is. The price of the car is 86. It's 13.2% off of 100%, leaving 86.8% of the original price. 86.8% of the original price is going to be the sales price. 86.8% of the original price $51,212. Absolutely. It's going to be the same thing. It works. That was 7. 8. An item is regularly priced at $25. It is now priced at a discount of 55% off the regular price. Use a calculator to find the price now. You can do this a whole bunch of ways, guys. You can follow what I just did. You can go either way here. You could say, okay, hold on. It is now priced at a discount of 55%. It is now priced at a discount of 55% off the regular price. What's 100% minus 55%? That's equal to 45%. It's 45% of the original price. That's 0.45. Use the calculator to get there. do a whole bunch of things. Or you could take the 55% and find the amount of the discount. A lot of ways to go here, guys, to actually get this. So a lot can be said here. I mean, I don't want to get, well, whatever. Let me kind of go for it, I guess you could say. It's going to be 125 less than 1250. So 1250 minus 125 is 1125. So I'm thinking, yeah, 1125. I'm coming out with this. You don't have to do that. Again, you can look at the calculator and go for it, but you just do the multiplication that's going to take place there, guys, and you got what you got. I'm saying it's 11.25. Again, so far I've gotten pretty lucky. I'm going to run out of luck doing this. We've got the calculator. We can always test it. But this would be problem number 8, of course, and let's see what that actually comes out to. Yeah, $11.25. Makes sense. 45% is a little less than half. Half of 25 is 12.50, $12.50. This is less than that as a final price. And 11.25 seems, okay, we get an answer that way. We look at it, okay? That's it. That's it. That's the correct answer. That's number 8. That's the price we got now, you guys. Forgive me. Looking at this answer key sometimes not the easiest thing in the world to look at, but it's good that we have it. Number 9. For number 9, suppose Heather places $4,000 in an account that pays 12% interest compounded each year. Assume that no withdrawals are made from the account. Follow the instructions below. Do not do any rounding. Find the amount in the account at the end of 1 year. Find the amount in the account at the end of 2 years. Sounds good to me. So basically, for compound interest, that P is all by itself. You don't multiply it with anything until you finish this stuff. Do not bring this in here. This is the rate, percentage-wise, number of compoundings per year, and this is number of compoundings times number of years. This is the formula for compound interest. There's some neat mathematics that gives us this formula. For our purposes right now, we're not doing any kind of derivation of that. But if you ever want to look at one, that's another class. It's pretty neat stuff. So what are we looking at here? We're looking at 2 different scenarios. We've got an A and a B. The A is saying for the A here, the principal is 4,000. 1 is 1. The number of compoundings per year is 1. It's just one time per year, compounded each year, at an interest rate of 12%. 12% has to not be used. Percents are kind of useless to solve a problem, literally to use. They're good to visualize a problem, but you got to make them into a decimal or into a fraction. We got it here. Number of compoundings is 1, and it's for 1 year. So that's this one. That one's pretty easy. You got 4,000. You take this whole thing. Do not bring the 4,000 in here. Do this first. Well, in this case, it's pretty easy. To the 1 power is just what it is. 1 plus 1.2 is this. That, again, you do the calculator on that one, but it should come out okay. Again, I want to check because I can make a careless mistake here and easily get the whole thing wrong. 4,480. Sounds good to me. The other one is going to be a little more difficult, but it's the same premise. You're using this. You're doing this. Forgive me for erasing this, guys. I probably made it worse by doing so, but okay, here we go. That's NT. Okay? Let's deal with it as they got it. I don't know how good this shows on camera, guys. I almost shouldn't have erased it, but I did. Okay, here we go. Okay, and we can always back up the film a little bit, see how I did it before. All right, guys, what are we talking about? Well, we're talking about the same kind of situation. Let's go. A is A. The principal is 4,000. A is A. The principal is 4,000. A, we don't know what it is. The principal is 4,000. 1 is 1. We got 0.12 to the 1. You're doing this after 2 years. So what happens is it's compounded each year. Assume that no withdrawals are made from the account. Let's go for 2 years here. We got this. At the end of the day, this does not come into here. This gets done all by itself, and at the very end, you multiply by 4,000. At the very end, you multiply by 4,000. So this is, so don't bring the 4,000 in there until you do 1.12 to the 2 power. In fact, let me kind of emphasize that, overemphasize that. This gets done first, then this. 1.12, the quantity squared, then you multiply it by 4,000. So let's see what goes on, guys. That's 5,017.6. .6 or 0.60. Okay, it looks pretty good. 5,017.60 looks pretty good to me. Number 10. Let's take a look at it. For number 10, Reuben received $1,800 bonus. He decided to invest it in a 5-year certificate of deposit, CD, with an annual rate of 1.43% compounded quarterly. That means 4 times a year. Answer the questions below. Do not round any intermediate computations and round your final answer to the nearest cent. You got an A and a B here. A, assuming no withdrawals are made, how much money is in Reuben's account after 5 years? B, how much interest is earned on Reuben's account after 5 years? That's going to be the difference between the two. Again, guys, we know, leave the P alone. Do not multiply the P into here until you're done. Number of compoundings per year times number of years. The 1 stays here. This is the interest rate in a decimal. So you got to convert the percent into a decimal divided by the number of compoundings per year. We've already been there. We've already talked about this. This is where it's going to go. This is where it's going to go. Here goes. Reuben took the $1,800 He invested at an annual interest rate of 1.43%. 1.43%, go over to the left 2 places, that's what it is. It's compounded quarterly, 4 times a year. N is the number of compoundings. T is the number of years. It's a 5-year certificate. And we got this. Basically, we have 1800. We got this right here, which is his own little dynamic, I guess you could say. 0.0356, 1.0356. 4 times 5 is 20. I don't know that that's right, guys. I'm trying to do a little bit of this in my head. So we're saying, now you took the 1.43% and you made the percent into a decimal by going to the left 2 places. You got this, and you divided by 4. You got 0.00. Apparently not. No, it didn't go. Okay, guys, well, we got a calculator too, I guess. See where that came out to like that. Okay. That's a 1 plus whatever this is going to be. Well, you know, there's a number of ways you could do this if you know where it's headed. I guess I could say if it was 160, it'd be 40. It'd be 4.25 less than that. So it'd be 155.75. I think that's what they got here. Well, I don't know. I'm getting all kinds of different answers, guys. I'm not gonna burden everybody during this film on this, but anyway, there's ways you can get this thing. I mean, I'd be getting 40. The 17 is 4.25 less than that. 4.25 less than that would be, yeah, the way I could do this, get rid of all the zeros, guys, in your mind and just say, okay, this is 143. Tell you what, let me make it 160. 4 goes into 160 40 times. Yeah, but this is 17 smaller than that, so divide that by 4, it's going to be 4.25. 4.25 taken away from 160 is 155.75. So basically, what you got, right, it'd be 4.25, take it away, 4.25 take it away from 40 is, right, it would be 35.75. So 0.3575 is where this is coming from. And then it comes out here. Again, you don't have to do this. I'm doing something I don't need to do. If you want to try to do in your head, go ahead and do so. At the end of the day, make sure you're confirming that this actually works. So let's see what we got here. So we said 0.43 divided by 4. Yeah, 0.00. So the 3575, but 0.003575, the whole thing to the 20. Sorry about that, guys. So this is not the way it's going to return. It's going to return this way. And what we have here is 1.00. I had the digits right, but I didn't take it. Looks pretty good. You got this to the 20. The 1800 comes at the end, you guys. What they're saying you got here is 1933.166. So that's 1933.17. So that's where we're coming from, guys. We're basically going there. That's what they got after 5 years. That's A. Well, what's this amount subtract 1800? This amount subtract 1800. This is the amount of interest they got. Now again, let's confirm this, guys. Obviously, I tried to get fancy, and the thing didn't go too well for me. See what we got. 1930, absolutely. $1,933.17, that's what you got after 5 years. Total amount in the account after 5 years is $1,933, $1,933.17. That is an amount of $133.17 that was made in interest. So, looks pretty good. Sorry about that. I tried to get. I told you I was due to get burned. I was hitting a few of these with the other films, but this one's kind of an interesting dynamic. I mean, basically, what you're doing is, if you're going to make it this big, you're making it 10,000 times bigger. So you got to make it 10,000 times smaller when you actually do it. You're getting, like I said, we were getting when we actually did it 4.25 less than that, and that's going to be 4.25 less than the 40. 4.25 less than the 40, it's going to be 35.75, but now you got to make it, you got to go over 4 places. Well, if you go over 4 places, to do that, you're getting what you're getting. You got the number that you got. Any number you're getting has already been made pretty big in that regard. So the way it goes is the way it goes. You're getting this. It's looking pretty good, you guys. All right. We'll talk again soon. Hello, everyone, again. I just wanted to add something onto the practice test number 3. Obviously, we did the solution earlier. I tried to do a few things mentally in my head, and it didn't go too good this time. Sometimes it goes pretty well. But basically, what you're looking at, and here's your final answer for problem number 10. This formula is very important, and I'd like to talk about it a little bit, and we'll just get to that over there a little more just on the side and just confirm what we did. A equals P times the quantity 1 plus R over N, that entire quantity to the NT. This quantity right here, before you deal with the P, has to be done first, then you multiply with P. You do not bring P into here at any point. You never bring P into here at any point for our purposes. I don't want to, it'd be one thing if you actually had the polynomial distribution that results, the polynomial that results from actually working this out and then multiplying by P. I don't want to go there. For our purposes, just know that you do not bring the P into here and then exponentiate. You take what's in here, you exponentiate it to the NT power, you get an answer, and only then you multiply by P. A is the amount or final amount, P is the initial investment, N is the number of compoundings per year, and T is the number of years for our purposes. This is pretty fascinating stuff. The derivation of it is not very difficult and very interesting when you're talking about compound interest. When this is taken to an extent where n becomes a big number, in other words, the shorter the duration of time within each year, when the shorter the duration of time within each year,
there is going to be a compounding. So the shorter and shorter the space between compoundings, n becomes really big, this becomes small, but this right here becomes really big. And in the limit, it deals with something. We get basically the exponential function, in a sense, e to the x, where e is a very special number. We're not going to go down that path, but I just thought this was something to mention. And like I said, in your future work in mathematics, there will be the idea of the exponential, there will be the idea of the exponential function where e is the base of the natural logarithm. A very special, fascinating number, e, the number e is. And this has a connection to it if n gets really, really big. When we were doing the problem earlier that the person invested $1,800, their investment was compounded quarterly. That means 4 times per year, so n is 4. The investment was at a rate of 1.43%, which is 0.0143. And again, 4 compoundings per year for 5 years. You work it out, you get to here. What's the difference between this amount and the 1,800? That's how much interest you actually got. So I wanted to put that into what we just finished with. Okay, so this will be right at the tail end. You'll see it when you look at it, I guess. This will be the tail end of this, and we'll just scroll through the answers for all 7 exams at the end of every one of these films. That's the plan. Okay, thank you, and we will talk about practice test number 4 very soon.